So welcome to the second day of the National Soil Moisture Workshop. We're going to be covering remote sensing mostly in this session. We had a dropout from Yuan, hoping to get some latest and greatest from a new satellite company, but they had to back out at the last minute. So I'm a fill-in, so that's my excuse for why this isn't a fantastic presentation. I've adapted a couple other pieces, and I'm hoping it is somewhat enjoyable. It's going to be a little more fun, I hope, for you, and it's got some information on it that could this for some of you. Maybe you want to check your email right now, but there's quite a bit of information in here that I'm going to try and plow through. I might go a little fast, so you can always watch the recording later and show me at half speed, just to keep on track of things. And this is something I eventually hope to get out in a bigger, more easily digestible, at least part of it. You'll see what I mean in a second. A more digestible format to help people understand the landscape of soil moisture, both internationally and nationally. But we'll get into that, and you'll see in 2 slides. But first of all, I am the biggest violator of this next rule. Come on, I'm up there, and come on. I'll just do that. All right. In situ, Latin for in place. It is not italicized. It is not hyphenated or underlined. I do this wrong all the time, and I finally have been corrected enough that I just want to share that with you. Several slides have showed very different ways. If you look at my publication list, I choose every different way to do it. I thought, oh, it's just supposed to be italicized because it's Latin, and you italicize Latin, but it's actually like it's a piece, it's a smaller part of a Latin. It's like etc. So if you don't italicize etc., don't italicize in situ. That's very simple. So I've started with Latin. I have you all ready to go here. So it's going to get worse. So we are a community. Let's go back to what's one of the larger communities, the United Nations. Why does Mike have the United Nations on a slide? Well, you'll see in a second. But United Nations formed after World War II, better than League of Nations. It's like League of Nations too. This is a way that we work internationally. How do nations collaborate? Let's go through the United Nations. UNESCO. You've all have heard UNESCO. If you all have heard of UNESCO, I assume, but who knew what it actually meant? I did not until last night. It is the United Nations Educational, Scientific, and Cultural Organization. Many of the things you do fall under that science part of that scientific organization. So when we collaborate with each other, we are probably operating under UNESCO in some way, shape, or form. They're trying to give us some overview or structure in which to work. Also, if you are in the climate sector, you have the United Nations Framework Convention on Climate Change. So UNFCCC, lots of fun acronyms. Oh, I have to get into this in a second. UNFCCC, something I've never heard of before, but you'll see why it's up here in a second. United Nations, or UN. UN is an acronym. No, UN is an initialism. It's letters, you're spelling out some other word. UNESCO, I've said it like a word. I've said it like a word, which means it's a NIM. It's an acronym. So I kind of call everything an acronym, but it's not really. If you have something that's you're spelling out the letters, if I say NASA, that's a initialism. If I say NASA, it's an acronym. Difference. Chad was like, oh my God, mind blown. So I always think, yeah. So I always think of meter group. I see meter group, it's like meter, METER. What does meter really stand for? Is that an acronym? It's not. It's just a term. So I'm going to just say acronym, and I'm not going to talk about initialisms, but just know there is a difference technically. It's one of the many uninteresting things I'm going to share today. So WMO, we're talking about soil moisture, right? And WMO is the World Meteorological Organization. This is an international group that's sharing information and trying to organize ourselves. So we all talk about meteorology in the same way. There's lots of subgroups to this. I'm not even going to get into them, but know that WMO, and the United Nations Environment Program, and the International Science Council. These are all things that touch on various parts of our work. And why do we have three? Because everybody likes a committee, right? Everybody loves making their own committee and having their own thing going on. But eventually they do merge back together and they start working. You have the World Climate Research Program. World Climate Research Program, WCRP, acronym you've probably never heard of like me, but they, along with the Global Space-Based Intercalibration System. Now we're starting to get to something that might be interesting. Intercalibration, I know that word. I know what it means. That's something that I'm interested in because we all want to talk and we're trying to all talk in the same way. We don't all have 16 translators like the United Nations does to have us talk to each other. We are scientists. We don't have that budget. We need to talk to each other. We need to talk and understand that we're using the same phrases and have a common language so that we can do big things. We're scientists trying to do big things like the Intergovernmental Panel on Climate Change, Nobel Peace Prize winning IPCC, who says, started in 1998, won the Peace Prize pretty soon thereafter, and solved all of our global change problems. Thank God that's solved. But that's another two folks, WMO and the Environment Program, got together for that. All three of those, ISC, WMO, and UNEP, got together for the Global Climate Observing System, GCOS. GCOS, I don't know how many folks have ever really heard of GCOS. You have to be pretty high up and pretty boring to have heard that. I'll throw myself into that, and Mike and I. If you're a Mike, maybe you've heard it. GCOS is something that, guess what? They care about soil moisture. That's one of their parameters. They're like, hey, this is important. Other things I think soil moisture is important. The GEWEX just had a meeting a couple of weeks ago, Global Energy and Water Exchanges Group. GEWEX is, at least one of them is one of their offices in Maryland. Peter Van Uvelen, who is a big supporter of soil moisture, it works with GEWEX, and you actually find some funding and other international, they're much more of an international player. Talking about this, there's a little bit of a mix up, but all this gets down to this ECV. ECV stands for Essential Climate Variable. That's the only green part I have on here. Soil moisture is an essential climate variable. It's an important parameter that we need to, or variable that we need to quantify if we want to understand climate. This is one of the reasons why all of you probably have a job. At some point, someone said, hey, soil moisture is important. We need to monitor this. It is an essential climate variable. So if you heard ECV, I believe soil temperature is. Should be, if it's not. There's a lot. This is not a soil moisture. This is not a soil temperature meeting. But you can look it up. Hey, you know what? Go look up GCOS and they'll give you a list. It'll be really entertaining. Don't do it before you drive. Just saying. If you have some trouble sleeping one night, maybe go read some GCOS papers. So this is all one side of this framework. It's getting worse. I'm gonna keep adding to this. We have European Commission. European Commission goes back to the 80s, where a bunch of European countries came together and said, hey, we need to work together. We're a bunch of Europeans. We're all on the same continent. If you're European, apologies if I screw any of this up. But they said, we need a space agency. I'm Belgium. I can't have a space agency. I'm too small. What if I work together with all my friends in Europe and we all have a common goal to monitor things? And they make the European Space Agency, ESA. ESA, you've all heard, they helped start the International Soil Moisture Network, the Soil Moisture Ocean Salinity Network. Hey, look, I got to remote sensing. And ASCAT, the Advanced Scatterometer, all remote sensing platforms coming out of the ESA group, the ESA program. So this is how we are, this is how we get when you talk about European Space Agency, ESA, and then these coming after. Also, the European Commission on Mid-Range Weather Forecasting, ECMWF. Wish that was an acronym. No, ECMWF. I got to spit that all the time. I never knew that EC stood for European Commission, but there it is. So it helps us track back. And then the EU comes along. Hey, we have the EU. That's a whole different group. And I can't quite figure out the difference between the member states are different, but the European Union versus European Commission, they do a lot of the same things. And ESA's like, hey, we're ESA, we're European Commission. And EU's like, hey, we want a space program. So the EU space program starts, and they form Copernicus. How many times have people have heard of Copernicus and Sentinel? These other things. You ever know what the difference between ESA and the European Union Space Program? Well, here you go. They're competitors, essentially. They have different funding groups, even though the funding groups are all composed of the same, pretty much the same nation states, all in the same quote unquote, pun intended, space. Oh, G7. G7 is not just a phone, it is the group of 7 nations. They come together and they say, we all want to work together. We have common purposes and goals. And for one of the things they want to do is we want to form a committee on Earth observing satellites. I'm getting there. Hold on. CEOS, at a meeting, they have the Economic Summit of Industrial Nations Working Group on Growth, Technology, and Employment. I'm going to lose my voice by the end of this. They formed CEOS in 1984, Committee on Earth Observing Satellites. Hey, all you countries get together and start talking and coming up with a way to talk about satellites in a common way. Because everybody's going to start launching satellites, we want to have some commonality, especially, say, anything VisIR is the first, any of the weather forecasting. Let's get that together and let's all record in the same frequencies. Let's have similar resolutions so we're not apples and oranges when we're trying to make a global system. For a brief period of time, G8, hey, Russia, you're our friend, come on in. Until, hey, wait a minute, 2014 comes around and they kick them out. So you'll see G8 out there as well, because G8 forms GEO. GEO is not just a car. You have the Group on Earth Observations, GEO. Okay, that is an international group still in operation, and they feed into GEOS, I'm not gonna get this one right, Global Earth Observing System of Systems. If you thought Network of Networks was fun, wait till you do Systems of Systems. That's a lot of joy right there. GEO and CEOS interrelate between GEOS, and then GEO also produces the GEO Global Agricultural Monitoring System, which means that, hey, soil moisture is important for agriculture. So they also have some joint experiments on crop assessment and modeling, which kicks out to an essential agricultural variable. GeoGlam produces the list and says, these are the important essential agricultural variables for monitoring. Let's include this, and now we have EAV. So soil moisture is both ECV and EAV. Many of us are probably on the EAV side of things, maybe a few climate folks as well. You're welcome on either side, but to throw that out there. And then on top of all this, they form the IGOS, Integrated Global Observing Strategy, IGOS, which is related to GCOS, and IVOS is another system related to this because it's visible optical satellites. And then there's USGEO, the US brand of GEO, and I actually serve on that panel on the subject matter side. And then AmeriGEO. You see AmeriGEO floating around. That's basically the Western Hemisphere GEO. Why do we have so many GEOs? I do not know. People like meetings. So they have AmeriGEO meetings, they have USGEO meetings, they have GEO meetings. GEO meetings, probably none of us will ever get invited unless you're a super bigwig. They're mostly political folks at GEO. They get nice, big fancy soirees. Not that I want to say anything bad about a box lunch. It was fantastic. That cookie was the cookie I had, and then the couple I stole were fantastic. But the GEO actually is on this kind of political spectrum, but they do kick down some questions to us scientists out there. That's the operational European. You want me to do more than that? I did run across EUMETSAT, and that falls underneath ESA, right? Yes, but that's ASCAT, isn't ASCAT or METTOP? They're off of METTOP. Yeah. Oh, this could be 10 times bigger. You want me to make it bigger? Because you're getting this next. Oh, what are these? Uh, I can go through this slide real fast, or I can go at the same speed as last time. What do you want? Do you want Mike, just get through this part? This is annoying. Or do you want more of this? 2x? All right, I'm gonna talk Jersey fast. Talking Jersey fast now. NSTC, National Science Technology Committee. They are politically affiliated mostly. They work with the Office of Science, Technology, and Policy, which is still politically constructed but has more subject matter experts in it. And their STPI is the Science, Technology, and Policy Institute, which is their contractor for most of the work they're doing uh, to basically provide continuity across science when it comes to transitions between administrations. You don't want to lose you want to be able to integrate with all these operational agencies. You can't just completely replace people. So OSTP is kind of that interchange between the operational science fields within the government and the National Science Technology Committee. Um, so the politics and the science do have to meet somewhere, especially when it comes to policy. So I'm going to run through a couple of departments. USDA is the easiest for me, Department of Acronyms. NRCS, we have some folks here, SCAN, T-SCAN. I'm from ARS. We have Forest Service. Forest Service is inside for the USDA, whether they like it or not. NAS, National Agricultural Statistical Service, Foreign Ag Service. I could have put them in the last international slides, but I kept them over here. And then NIF are the National Institutes for Food and Ag. National Institutes for Food and Ag. Why is that? That's weird. I've never heard of that before. You've heard of NIH. They're trying the same branding, just food and agriculture. So many of you land granters out there will know NIF as used to be CSREES maybe. But they are a funding group. So if you want funding for soil moisture, NIF is one of those places. Jim Dombrowski there does a lot of that. NASA, acronym NASA, has the Earth Science Division. Within that, there's Terrestrial Hydrology Program. There's SMAP. I'll go into these a little bit more later. But Terrestrial Hydrology Program has SMAP. The Terrestrial Ecology Program has NISAR, did it wrong again. NISAR, which is a mission that'll launch next February, hopefully. And then Cygnus is currently flying, and I think someone actually had it on a slide, Snoopy, SNOOPI, is another small sat or something that's going to monitor, I don't know if it's on the ISS or not, but monitoring soil moisture. So that's where NASA comes in on soil moisture. Domestically, Department of Energy, they have the Atmospheric Radiation Measurement Program and the Nuclear Regulatory Commission, because soil moisture is one of those things that helps spread out radiation. So we got to understand what the soil moisture is. One of my first jobs that I got rejected from was working at the Yucca Mountain Project, where they said, no, Mike, you can go find another job somewhere else. You don't need to work here, because soil moisture is a conduit for the transmission of radiation. DOI, we have any USGS folks in? I think we had one at least. USGS is very involved with water, and soil moisture is water in many ways. They also have the BLM, Bureau of Land Management. Bureau of Land Management, big landowner, not the biggest. Who's the biggest landowner in the country when it comes to departments? U.S. Forest Service. But right up there next to them is BLM, Bureau of Land Management, or Bureau of Rec. If you have something to do with a dam, Bureau of Reclamation, TVA, and Tennessee Valley Authority. Bureau of Rec's a lot of the western states. TVA's Tennessee Valley, obviously. Soil moisture is super important for flooding, hydroelectric generation. So Department of Energy it combines with DOI there a little bit. Department of Commerce. Why is the weather in commerce? I don't know. But they have CRN, National Water Model, National Weather Service. Oh, okay. There you go. You know, he gets to appoint that person, right? Even when you're into politics, you can't stand your own politics. But underneath NOAA is NIDIS. NIDIS is actually multi-branch. It's National Integrated Drought Information System. USDA has a partnership there. A couple other Ds are in there as well. But that's where the National Coordinated Soil Moisture Monitoring Network finds its home. Then we have DoD. Obviously, a lot of these acronyms and names. You have Army Research Lab, Army Corps of Engineers, which manages the upper Missouri River Basin, Air Force and Navy. Why does Navy care about soil moisture? They have their own weather. So they need to know the land weather, which influences the water weather to help them ship and move things around. They also have the Marines. And Marines care about where they can land their tanks. And there are other things that they need to have trafficability. When we talk about where does the Army need to go, the term there that we like to say, politely is trafficability. Can we get our vehicles with big things that shoot big things onto the ground? Trafficability is our keyword there. The National Navy Research Lab and the NGA. NGA, little joke. Nobody here is from the NGA, right? You couldn't admit it if you were. National Geospatial Information Agency. Geospatial information. That sounds like two words. You only given it a G. Well, they like to be three letters because CIA, FBI are also three letters, and they want to be in that same space. So NGA, they put a hyphen in there and do that. Health and Human Services, HHS. Why is Health and Human Services on this list? Well, CDC, Centers for Disease Control used to have a lot of partnerships with NOAA, and understanding the moisture in the air can really influence asthma. The moisture at the soil can influence asthma, coccidiomycosis, many other diseases and transmission. So soil moisture is of importance to CDC when they have the funding to support it. NSF, obviously, states, obviously, which have their own mesonettes in many different forms there. Tribal lands are sovereign nations inside the US. We've had that beautiful talk on yesterday. So the interaction with those groups is something that we have to be mindful of. And there's many opportunities for discussions on water resources, climate information, and adaptation when it comes to working with tribal lands. And something more recent, the US Global Change Research Partnership, I think is partnership there. Program. See, I can't get them all. Have the National Climate Assessment. They also have the National, which just did their 5th release last year. Then the National Nature Assessment, NNA, is just starting. They haven't done one yet. Both within these, there's the GSIS, a Global Change Information System, which is one of those places that they're trying to put all of the information into one place. So we might hear about GSIS. And then within the weather forecasting system, the Office of Federated Climate, OFCM. What's OFCM stand for? Office of Federated, can't remember OFCM. They're gone anyway. It's not now ICAMS, the Interagency Committee on Advancing Meteorological Services, ICAMS. They're not fully spun up yet, but that's another interagency group in the federal government that cares about soil moisture because soil moisture influences meteorological services. That was a lot. So that's the international space and the domestic space. I'm way over my time anyway, but let's go into why I'm here. CEOS, Committee on Earth Observing Satellites, has land product validation subgroup. They have currently 10 subgroup focus areas that are looking at different products, above ground biomass, land surface temperature, vegetation indices. Soil moisture is one of their variables that they're worried about. And we've produced a product. The current leaders are John Bolton out of NASA and also an NCSMN core team member, and Alexander Gruber, who's at Vienna University of Technology, and did a lot of work with the ISMN early on. They're trying to coordinate the international efforts for standardizing the way that we verify satellites are accurate. We produced a protocol, soil moisture product validation good practices protocol, not the best practices protocol. We don't want to tell anybody how to do things. We just want to really nudge them in the right direction. So we say good practices, trying to convince people that this might be the best way to go or the right way to go, without excluding certain, because it can change depending on your locality of what might be a good practice and not a good practice. So this is online. You can find it very easily searching that term. Why do we need to have it understand all these protocols if we all agree they're essential climate variables and essential agricultural variables? Well, we have lots of different ways of measuring or estimating soil moisture. In fact, no satellite measures soil moisture. They all estimate it. That's a big distinction, right? They're all measuring in some C-band, X-band, radio wave spectrum that they then interpret or model back to a soil moisture estimate. Nothing's measuring soil moisture from space. They're all estimating it. That's it. If a sensor in the ground is also estimating. Now, a lysimeter might be one of the few ways that you're actually measuring just soil moisture. So AMSR-E measured from 2002 to 2011, GCOMW or AMSR-2, WINSAT, which is a DoD. Why did I have that DoD slide before? Well, WINSAT's out there, though you can't get the data usually. ASCAT, European SMOS, ESA. Aquarius, a 3-year mission that was NASA and Argentina working together, and they in the same spectrum that they're measuring ocean salinity, just like SMOS is soil moisture and ocean salinity. Aquarius was dedicated towards ocean salinity, and then they said, "Hey, wait a minute, we can use this for land." Except the footprint was huge; it was 100 kilometers, so very generic numbers, very generalized numbers, continental scale numbers almost. But it is a product that's out there. Then you have SMAP and their variety of products. A little bit more on a second. Cygnus is out there. That's a slightly smaller footprint. It's making use of some other information that's out there. And if you don't know, you have an L-band receiver in your pocket, most likely, unless you're checking, and plus unless you're playing Pokemon Go right now. Your GPS receiver in your pocket on your phone is an L-band receiver. L-band is a protected system. It's our optimal system for measuring soil moisture. That's how we transmit, because it's a protected science band. It's meant to transmit GPS locations and signals from GPS satellites, and also be used for the SMAP mission, the SMOS mission, the NISAR mission, because L-band's protected. You don't get these weird stray releases, or it's not supposed to. And it's the most sensitive band for soil moisture. So it gives us our best estimate usually, and it's protected scientifically. And that you can see this is an old slide. That launch date of September 2022, obviously passed, and we're now at February 1st, 2025. They have had some issues, to say the least. So we have all these satellites. They're flying over. They're giving us huge footprints right now. We're hoping to have them advance to much smaller if they are on a 40-kilometer resolution. But our measurements are all the size of a soda can in the ground, or maybe slightly larger. How do we scale them up? Okay, by a lot of elbow grease and hard work, and you and folks like you going out and making measurements and understanding the landscape in which you're monitoring soil moisture at your network locations, at your field scales, at your watershed scales, to get up to these points. The SMAP mission started out with a 36 kilometer product. They went to a 33 kilometer product through some magic of, they basically wanted to keep a different grid. Gridding and geodesy, another thing, how is the landform oriented, all becomes a great challenge for them of trying to make those pixels line up so they have the common reference maps between their satellites. So 9-kilometer product is the enhanced product. They've now gone down to a Sentinel mixed SMAP product, which can get to a 3-kilometer or even a 1-kilometer. And then some other folks have added on and gone to what Hydroblox was, a 30-meter product, all with some other satellites mixing in to the algorithm to produce a downscaled product. But most of those do not actually produce very good numbers at all conditions. They have some don't restart. Hold on. There might be a restart here. Very small numbers. Come on. So we saw some maps of all the stations across the U.S. These are all Mesonet sites, national federal sites. This actually is a published map that we made. If you were to look at the 36-kilometer grids, which is a slightly more than 500 square kilometer grid cell, this is what we call the EZ2 grid. And these are all the sites in green that have at least one station in that grid cell. If you look at New York State, doing a really good job. Oklahoma, really good job. Utah, actually quite well, because you have the Utah State Network that's released, and then you have SNOTEL helping you out, SCAN helping you out over here. But many states have very few, if any. Everybody has at least one, but some states really don't have great representation on this map because they don't have readily available data. But this is what we're trying to make. We want to make this map green. Sorry, Hawaii and Alaska, I don't have you on this map, but we'd like to get you there. I just have to learn how to make better maps. We have a protocol out for how to do CalVal, but the answer really is a good CalVal program has good data at the ground. So good data at the ground comes with quality assurance going in and quality control coming out. Ways of doing that are having lots of metadata and lots of ancillary information, having relative humidity, having rain gauges, soil temperature, good power with the solar panel, and having secure boxes, NEMA boxes, enclosures that don't get wet or have rats and bees living in them, or ants. How many times do you have an ant-proof does Campbell have an ant-proof system? My technicians hate ants when they open them up. They're not as bad as bees, but bees tend to not come into our boxes, but ants do. They can get anywhere. So long, consistent data records really help this. All of these images I'm going to show next are coming out of the Job protocol I'll point out in a second. But we have good data going to the ground. We have our preferred data, our preferred depths. Most satellite missions want a 5 centimeter depth. That's what the L-band system really, the deepest it can go is 0 to 5. So that's what that 5 centimeter depth is. When Tyson was talking about what are the best depths to have deployed, every single one of them had a 5 centimeter because that's just what we do. It's probably one of the easiest to install, but also one of the toughest ones to really count on because it can break pretty easily or get exposed, or stepped on by a cow. But it has this ready, it's ready to go for comparisons to satellite products. They don't really want anything deeper. They want they want to know when it's a light rain and they get a signal there because that's what they're going to see with their satellite. The way we install, this is just from that paper again, but we'd really like to see that 5 centimeter depth for remote sensing. When you start to get into vertically installed or something that's going to have a larger integration space, you're starting to deviate away from that very skin surface, which is all you can see with an L-band system. If you have a P-band system, P-band can go a little bit deeper, but it's also not a protected science band. So that's where you get these influences from, say, NPR or anything public radio access, really can impinge upon the P-band signal. This is where Snoopy is in that space, I believe. And there's some other P-band instruments out there, but you have to be really worried about interference and trying to mitigate that. And it's not a constant interference either. It's like all over the place. So you have to almost sift by hand to get that data good. L-band protected, but only at the near surface, 0 to 5. More information on here's our holes in the ground that we're putting in. We're going to have good data loggers. We're going to have good long time series. That's what we always love because long time series helps us knock out some of the variability from sample to sample. I go out and take a sample, then I have a student that goes out and take another sample. What if they take a sample different from mine? Well, then we have this other variable in the mix that we have to worry about. So having one sensor in the ground for a long period of time gets rid of all those other variables like installation method, because it's one installation, it stayed in the ground. Anytime somebody says, I want to have a station in a field, I say, great, you're going to have 3 months of data. But I really need to know what's in the field. And I said, great, but don't come to me and tell me to drive my plow around the sensor because they're not. They're just going to run it over. And I'm only ever going to give you 3 months of data in a field, or I can give you the winter data. That's nice. It's frozen. But and our sensor doesn't work in the winter. But this is long-term data is the most valuable. That's why we go in undisturbed and off the side of the fields installations generally, because it gives us this comparison that spans all these other missions so that we know how one mission compares to another mission. Just like we have one sensor, we want to compare to the next installation sensor. Sometimes when they do satellite decommissionings, they hold them off from a decommission until the next one's flying, and they can do an intercomparison. Usually get a couple months of that before they turn the old one off, because they've got to know, they want to have a long-term record. And that's the most important part for our protocols. And if you're wondering, how do I do a protocol? And Campbell did a great job of showing us in the field. Chris and Chad stuck their arms in the holes and helped us and showed us how to install. Part of a field school we did last year as well, and we're trying to embrace that more, is training people on how to do this. The SNOW community does this as well. They have an annual meeting for SNOW. They have a European version, a US version, a SNOW school operated out of CUWASI, another acronym. That is a consortium of universities for advancing hydrological sciences incorporated, CUWASI. That's a big one. They run a SNOW school, and we're trying to get a soil moisture school spun up with them so people can now go and train on how to make these measurements, how to install stations. And NCSMN is also in that range. But in the meantime, we have a document. A couple of years ago, they said we need a protocol to install things. We could follow. I know Campbell and other groups have installation protocols online, but the entire suite from site selection through to installation and data cleaning is really where we're stepping in. We have on the Journal of Visualized Experiments a video that I'm not going to be able to show But there's an actual document and accompanying video to show you the steps of this installation. And that's where I'm going to end. Super late, but this document's out there. We can share the link later. I invite you to get it's wide open and free. Anybody can go watch it. There's a accompanying physical document as well. But the installation protocol is where we start on CalVal. We want to have a good CalVal point measurement, and then we're going to go through our quality assurance and quality control steps afterwards with our next document to help people understand a good data set going into the CalVal program. Because I said we're going into 40-kilometer products to start with, but we're going to soon get to a 200-meter product with NISAR. And that's something that we can actually, sample in a day. So we could have station measurements and compare them to a field and have really accurate high resolution products on a 12-day time scale. So that's my last slide. Sorry for putting you through those first two slides. I'm ready for any questions you may have. I am going to try and make those two slides. I have to correct myself on some things and then make an actual video of explaining everything in more detail and not at double speed.
Mike, I think that type of information is so valuable to all of us because we're constantly throwing those acronyms. We need to actually post that on our website, on our Knowinitis website. I mean, that people look for that kind of information all the time. And I would invest the energy into making that as formal as you possibly could with as accurate and put that as a research tool on our network website.
That was not an easy slide. Those were not easy slides to make because when something changes, tracking down when something changed was a nightmare. Scott. So my goal ultimately with that kind of information would be a web page or something with links to web pages or documents that describe them and their history, each of those steps, and then the pertinent status. So like there's an IPCC like regular update, so people can navigate themselves to the right location because they often don't talk to each other. And it's hard to keep track. They silo themselves and they don't jump between. You can find any of those lines are a direct connection, but there's nothing breadth wise that's really encompassing like that. So
I don't know that I need the microphone, but just as you think about the depth and breadth of soil moisture monitoring, I just wanted to bring up that a number of years ago, NASA actually sent a dielectric sensor to look at soil moisture on the Mars surface. And so if you think interplanetary, there are people that are, measuring soil moisture or regolith moisture on other planets.
that's a whole nother slide.